is going to be about Beyond Earth Building the Order Space Economy. For this, I have privilege to invite our dignitaries on the days. May I now invite our session moderator, Dr. V.S. Hegde, former scientific secretary, ISRO and CMD Antariksh. Please, sir, join for the dais. I kindly request our panelists to please join in the dais. So I request Dr. Siddharth Pandey, Protoplanets. Please, sir, join. Now our next panelist, Mr. Arun Radhakrishnan, Inspecity Labs. Welcome, sir. Next, our Mr. Rajat Kulshreshtha, CEO Space Machines Company. And Dr. Ashok Saxena, CEO Space TS. And last, Mr. Naresh Kannan, OrbitAid. So, Dr. V.S. Hegde, our moderator, please start the session, sir. Thank you.
Yeah, I think audience is thin, expected, because most of the guys are either checking out or checked out. So I have an advice from the organizers that time management now is pretty crucial to make it for their flights and all that. So I will be very brief. It's a privilege to be with, the hardcore techies and tech firms who are into the business of doing their or carrying out their activities in outer space. We are all aware that, initially space programs world over started where we started looking towards Earth from space. And slowly we started looking at space and outer space from space. Obviously, the activities grew in that direction, whether it is, construction in outer space or fueling or refueling in outer space, or handling the space objects and debris in outer space. And various things started where lots of activities in outer space, and which was initially considered to be the prerogative of, big national space agencies or governmental space agencies. Now, private also has with equal zeal, they have entered into really carrying out space activity in outer space. So obviously when we talk of space economy as 600 plus billion or 450 to 600 billion today, that's the kind of figures, of 650 going to grow to 1.2 trillion, 1.8 trillion in the next few years, all such things. I hope it factors the economy in outer space as well. But what gives me really thrill when I hear about activities in outer space is the kind of activities one is envisaging. See, other day we heard or we saw 2 Chinese satellites, one Chinese satellite in GEO was refueled by another in GEO. Docking happening there, refueling happening there, and, asteroid mining, establishing lunar base, and so many things. So I will not be yakking, cutting short the distinguished hands-on panelists I'm privileged to be with. So I will straight away request and Siddharth to give a keynote of 10 minutes. And I am taking the liberty of not spending time again on introducing each individual. So my request to each panelist would be, in case you want to tell a word about your company or the activity that company is doing or envisages to do, kindly feel free to do that. Now what I'm thinking is, a couple of panelists, especially Arun and all, felt, it could have been a round table we would have discussed. So what we will do is, after one round, I will go to audience if they have any focused question. Then I'll go for the second round so that, you can top it up, whatever you have stated. So Siddharth, please.
Can you hear me? Okay, thank you so much, Hegde sir. I will kick off the discussions with my company Protoplanet that I registered last year. And this is a coming together of about 9+ years of efforts to establish space exploration training, particularly for astrobiology, space biology, microgravity in the country. And we are working in the capacity of almost, you can say, in a consultancy capacity building role with ISRO, Human Space Flight Center directly, and also with research institutions and universities on some hands-on training on certain aspects. We're also part of the Space Tutor program of the Capacity Building Program Office at ISRO. So I'll speak particularly about the analog aspect of our company, wherein we are mainly focusing on the training of systems and humans in the analog conditions. So when I use the word analog, I mean naturally occurring locations on our planet which help us create certain conditions or give us access to certain conditions to train robotic systems, to help calibrate certain instruments, and also see the effect on humans and do human performance studies, mainly for astronauts, for the future missions to Moon and Mars. And they're complementing the lab studies and validating some of these existing system development efforts in these naturally occurring environments. India has a variety of diverse analog sites, high-value sites. Particularly, we have been focusing on Ladakh in the Himalayan region. And there are other locations which all offer unique capabilities in different aspects of how they are useful to the different missions. The other aspect is that there is a growing list of opportunities that is available through the upcoming missions, whether it is the human spaceflight missions or the robotic missions, planetary science missions, which require us to accelerate the development efforts. And that these are all motivations for us to go in and do this level of effort. I have just summarized some of the imperatives of analog testing on this slide, which help bring down the risk. You can test the prototypes in relevant field conditions to mitigate the design flaws. To mature the technologies, normally it's done towards the last stage of the technology maturation for several critical technologies required on the surface of lunar or Mars. In terms of operational concept validation, so a lot of the concept operations can be tested in a simulated environment where you can actually remotely control an asset that is deployed in this remote condition and test out the whole chain, the human training, all the communications aspect of it, and the deployment of the instrument as well. It all can be done in that environment. The scientific contextualization, again, very important, because you have these naturally occurring conditions that help space scientists who are interested in Mars and lunar surfaces. They can study the phenomenon on our planet and do that. And lastly, of course, crew training. So not just for astronauts, but also for the ground crew that is part of the human missions. This whole ecosystem helps them understand that environment. This is just a summary slide to say that we have been studying all the different regions in our country and looking at which are the main analog environments and how are these environments important to develop some of these instruments, which are the relevant technologies that can be tested there, what are these environments analogs to, and which are the upcoming missions that they are relevant to as well. So when we say analogs, it's not just about a technology or a experiment. It's about trying to characterize the environment, and it's a very complex environment. So you have to break that down and then essentially derive what are the near-term objectives that can be achieved here. Ladakh has been an excellent location for about 7-8 years now, where we have had teams of individuals come through from different countries. We've had teams in India that have been collaborating with them. And essentially, it's an early Mars analog. That's one of the main motivations why we went to Ladakh. So speaking about the scientific context here, that Ladakh today is what Mars was like billions of years ago, when it was a warmer, wetter planet. So what we see in Ladakh right now, it's a time capsule of what it would have been on Mars when it was slowly losing water. And what that does is it creates these conditions where microbes are living in these extreme environments, and that helps scientists understand and answer some of the questions and build out missions and experiments accordingly. At this point, I would like to make an announcement about our upcoming expedition. So we work closely with several research institutions, and now we are formally working with the Human Spaceflight Center as well on Spacesuit Bound India in 2025. It is happening from 18th July to 27th of July. And we also have a one-day workshop in Ladakh University on the 25th of July, which is a free event. So if you're interested to be part of the discussion on how analogs can help be part of space missions, we plan to host a discussion there as well. We also are forming some key strategic partnerships. We are working closely with several organizations in India and outside of India to enable some of these discussions. As Protoplanet, we are a facilitating organization that sits between government and academic institutions, government and industry. We are a network of about 30 plus subject matter experts. The idea here is that there are people who have already done a lot of this experimental work. What is lacking right now in our ecosystem is having that insight and knowledge. So we are able to inject ourselves into some very key projects and then provide that information that is needed by startups, that is needed by ISRO, which is looking to spend money on these things, so that we are able to bring in some of the, increase the fidelity and, improve the feasibility of some of the studies there. I did want to call out SIA-INDIA as one of our network partners, and through them, it is helping us connect with the industry here in India as well. The other announcement we made last month at GLEX in Delhi was we are partnering with Ladakh University to establish a robotics yard, Ladakh Analog Robotics Yard. So similar to other robotic yards that exist in other parts of the world, this will be an outdoor facility in Ladakh that will be allowing teams of researchers to come in and test out their robotic instruments, as well as even some of the habitat mock-ups. We are partnering with Spartan Space in France, which is a French company that does similar work with the European Space Agency and Kannan. So they're partnering with us to bring in some of their habitat mock-ups as well. And this year, as part of our workshop, we will be inaugurating and commissioning this test yard, and hopefully by next year, it will be open for teams to come in from within India. We want to give this opportunity for Indian universities and institutions, because many a times that is lacking to get the right kind of environment. And also for ISRO, as it's embarking on more and more complex surface operation missions, we hope that such facilities can complement the existing facilities on their campus. So just to summarize, like some of the robotic systems development, that effort that is taking place. So, when you look at rovers, you want to conduct things like slope studies. You want to understand how naturally, so there is one is, you can artificially create this in a lab. But when you take these systems out into the natural environment, it is a very different kind of a test, wherein you are having a lot of different variables that are impacting your system, and you're able to do that complex simulation of an environment on Earth that you will only be able to find in places like these. Also, the operations of the robotic arm, the drill, when the rover is going up, doing those kind of operations, how do they perform? Doing drilling on the surface of Mars, on the surface of the moon. All of those kind of systems are always tested on Earth in conditions. And integrated mission simulations. So it's not just about that one rover or one instrument, but the whole chain of individuals who are involved are also getting that training, who are able to understand what it is like to be part of such a mission. As far as the human spaceflight is concerned, the goals are slightly different. But I did want to point out that Analogs has something to offer for robotics community and for the human spaceflight community. With regards to human spaceflight, there's things like habitats, life support, EVA operations, suit testing, human factors, all of these different aspects. As part of our expedition, we'll be making an announcement on the team as well as the other partners in about 8 to 9 days from now. We are doing some aspects of both robotic and human testing in Ladakh. So just to summarize, I guess, some of the synergies are that as Protoplanet, we would like to help develop some of these high fidelity, site-specific kind of simulant environments, work closely with researchers who are doing a lot of lab-based work, and then provide them that environment to do this kind of tests, and create these integrated test beds where a communications company can come in, set up infrastructure, and test out, for example, a future lunar communications network on the surface, and at the same time simulate talking to the Earth by having a ground station in Bangalore or Hyderabad, for example. So there are all these different kinds of tests that can be done there. And lastly, the logistics and operations of it as well, because we have been doing it for over 7-8 years now. We work closely with permission from the Ministry of Home Affairs, External Affairs, the local Ladakh government, wildlife, defense. So we have a really good understanding of all the site access protocols, which we take very seriously because these environments are very fragile ecosystems. And as we are bringing in more and more individuals and technology there, we take a responsibility to also ensure that these places are conserved and we abide by all the regulations there. So I guess that's my time. Thank you very much.
Thank you. Thank you, Siddharth, for your crisp presentation. And may I know, I think we will come back. May I now request Mr. Naresh Kannan to make his brief remarks?
Hi everyone, good evening. So I'm Naresh from a company called OrbitAid. So basically what we are doing is deploying fuel stations in space. So as a part of that vision, we have developed our own docking and refueling interface called SIA-INDIA. Not just in theoretical terms, we have actually achieved TRL 7 for it, and I've done a couple of zero gravity tech demonstrations where we demonstrated how refueling sloshing dynamics could work in a simulated space environment. So that is a sort of progress regarding our technical maturity. But just to sort of give my thoughts on the sort of role refueling could play in outer space economy is I'll just give you a simple practical example. So imagine you have a car, and if your car runs out of fuel, you don't throw it away. So that is what essentially is happening in space, where if your satellite runs out of fuel, is either deorbited or decommissioned. So it is not a sustainable way of developing or having a human presence in space. So we have ambitions to go to Mars, go to Moon, but for that to happen, we need to have some sort of architecture where the constant pit stops would help us go beyond Moon and Mars. So that is our a role in contributing to outer space economy. So thank you very much, sir.
Thank you, Naresh. I mean, it's extremely novel that you're thinking of fueling in space. So great. Now may I request Rajat, CEO of Space Machines Company, who is also working with Indian companies under Space Maitri program of Australia. So let me request now Rajat to make his remarks.
Thanks for that. So I guess talking about the topic for the panel, when you think about extending a more sustainable presence in orbit, there are three major pillars from our perspective. You need security, you need transportation logistics, and you need resource utilization. And I guess we're focused on the first pillar of that, which is security. I think for us to be sustainable in orbit, you need that. And what's happened over the last 5 years at a rapid pace is you've had a situation where the space is getting heavily commercialized. There's a lot more satellites going up, which means there's a lot of congestion starting to happen. And that talks to failures through collisions and other things. And it's getting more and more contested. So, more and more countries are recognizing that it is the ultimate high ground, and it needs to be protected, and it is a war-fighting domain. And at the end of the day, it's becoming super critical to our life on Earth. So every critical service that we have today depends on some level of space data and services. And so when you think about $1.3 trillion worth of infrastructure in orbit, not being able to maintain it, protect it, secure it. For comparison, $1.3 trillion is the oil and gas industry on Earth. So if you told the oil and gas industry you couldn't protect it, you couldn't maintain it, you couldn't reach it when needed, that would not work. And so when currently something goes wrong with a satellite, if you normally can't respond in time, you cannot respond. It takes weeks, months, maybe years to respond to an event, whether that's a catastrophic failure, whether that's a collision, whether that is a security event. Even if you could respond to it, it's cost prohibitive. So you can't really pay hundreds of millions of dollars to do refueling and other things. And the third part of it is that we just don't have coverage. You can't reach every bit of infrastructure. So at Space Machines, we're focused on building what we think as first responders for space, which is an ability to have distributed space security, the ability to get to an asset very quickly, characterize what's going on from close proximity. Now, currently we do have telescopes on the ground, that you can see some assets. Then you have near-Earth imaging services in orbit that allow you to take pictures, but you really don't understand what's happening with that asset from close up. So Space Machines company is focusing on building systems, Optimus Viper, which is the spacecraft, the first responder, and an AI-driven software called Solstice OS that helps us deliver those services. Thank you.
Yeah, I mean, you made an extremely important point in a very concise manner. Yes, the ISAM, or in-orbit servicing, assembly, manufacturing, resource utilization, these are not only crucial to commercial growth, they're also the matters of importance to national strategy. So thank you, Rajat, for that comment. Now, can I request Dr. Saxena, Ashok Saxena, to make his remarks?
Thank you.
No. Good afternoon, everyone. I'd like to thank SIA for giving me the opportunity to be here, and speak at this esteemed gathering. And thank you, sir. Our company, Space TS, does very little related to this topic directly. Indirectly, yes. But I don't want to dwell on the company, but focus on the topic. But very briefly speaking, the company is infusing artificial intelligence into space vehicles. So we are not, unlike most companies, we are not working on payloads. We're actually using artificial intelligence to make the space vehicles smarter and perform better. Now, when I was first asked to come to this forum, I was wondering why I should be here, But I realized that I was a dreamer and a doer, so it makes sense to talk about these dreams, And I'm also fortunate to be here at the Indian Space Congress, because the Indian dreamers were one of the first to think about outer space colonies and intergalactic travel. If you read the Mahabharata and many of the other Puranas, you will find references to space travel. In fact, in the last century, there was a book called Vimanakya Shastra. Okay, it was written by a Pandit Shastri, and there were 800 shlokas on how to design and build space vehicles, Now, with that introduction, people might want to know, okay, why are we wanting to go outside the Earth and build space habitats and space colonies? So the first thing I would like to point out is that there's a difference between space habitat and a space colony. A space habitat is where human beings grow, live, and interact and form a society. But a space colony implies the implication of territorial rights. It means somebody governs that group of people and they control the community, Now, why do people want to go and build space habitats or colonies, One is the sheer, most basic desire to explore. And there are others who believe that, okay, we have this technology, let's go out and do this new thing, A third reason is mining. And I will get to that a little bit more, mining in the moon, on the asteroids, and even Saturn. I mean, what are the differences and possibilities, But one of the things that Elon Musk and a lot of people talk about is really that we need another place to live, otherwise mankind might just disappear, Because the fact is that over the last millions of years, 99.9% of the forms of life that existed on Earth have vanished, okay? So there is a possibility that mankind may also vanish, Now, one of the great astrophysicists, Stephen Hawking, okay, he has predicted that we have about 120 years to live, okay, that's it, but I don't quite believe that. There are other theories, there are other computer simulations which show that, okay, we have 780 years or 800 million years. But, these are all far out. I mean, not our generation problems. But this is one of the reasons people justify why we should be looking at other places to live, Now, where can we have these space habitats or the space colonies? Well, there are a couple of things that you need, One is you need to be either close to the Earth, close to the Moon, or you need to be on the Moon or on Mars, and of course at the Lagrangian points, where it's relatively stable. So most colonies or habitats are predicted to be in one of these locations. And when we talk about the Lagrangian points, I cannot help telling you that one of the greatest proponents of these colonies was O'Neill. And during as recently as the 1980s and 90s, he was extremely popular, and he was designing colonies that were 35 kilometers long and 8 kilometers in diameters, okay? 2 rotating spheres, and so that you didn't need to completely, keep thrusting, keep them going. There's artificial gravity on the inside of the cylinders. There was agriculture. There were windows for sunlight, mirrors, and so on and so forth, and an atmosphere of oxygen and nitrogen, So people have envisioned, designed, and even the President of the United States has recognized it and promoted this concept at one time in the 1980s, Now, you might also, the next question is, what kind of, I said that we were going to talk about minerals, Where will you find minerals, and does it make sense to really look for minerals, And I would just give you one example, that NASA has awarded contracts to 3 different companies already to go and mine minerals on the Moon, So they believe that there is a future there, The minerals include rare earth elements, and these are very important. And if you looked at the geopolitical situation, there's a lot going on between America and China and even Ukraine about these rare earth minerals, So there is quite a lot of abundance of rare earth minerals, not just on the Moon, but also on the asteroids, So people want to go out and mine, and then what would you do with the mining? One is that using the materials, you build space colonies or space habitats in the near vicinity of where they are mined, The other is the Earth is running out of supplies for the rare earth minerals, and therefore you want to mine them and bring them to Earth. And the third most basic issue is a supply chain problem, If you are nearby an asteroid or the Moon, then you can build a space habitat there, I think those are most of the things that I wanted to touch on about outer space and building habitats and colonies, why we are doing it, what might it look like, and what are the advantages and reasons why people want to do it, Thank you very much.
Thank you, Dr. Saxena. May I now request Arun to make his brief remarks.
Right. Can you hear me? Okay, that's good. All right, so it's quite hard to actually, figure out what to say, because we have some excellent panelists out there who have actually, spoken about all the possibilities of the outer space economy. So Dr. Saxena, you have spoken about mining and cities in space. And essentially that's what Inspecity wants to do. We want to build a giant city in space. Again, inspired by the O'Neill cylinder, which Saxena spoke about. And my sister companies in some way, OrbitAid and Space Machines Company, they're looking at maintenance and preventive care of satellites and orbital assets. So I think that's the whole thing, actually. I think my talk would just be to summarize what everybody is doing in some way. So while we speak about colonizing, Moon, Mars, and the other planets, I think at this point of time, looking at the limitations of the technology that we have, it's always important to take just a step back and see what is the immediate need out there. And primarily, it would be extending the life of satellites and the immediate, orbiting infrastructure. So let's say that we are going to mine the asteroids, or we are going to mine the moon. I think if you take the mining industry on Earth, to actually mine, a certain area, you need to have the support infrastructure. You need to have drill bits, you need to have mechanisms, you need to sort of maintain them. If something goes, breaks down, goes wrong, you need to actually change it. And that is something which needs to be done on the space side of things. So when we talk about servicing, people think it's a very far-fetched idea. But the fact that we cannot service a satellite that's 400 kilometers above, but we are thinking about going to Mars and colonizing it, I think that's even more far-fetched when you think about it. So I think our sister companies here, which are on this panel, is trying to look at the immediate problems, both in terms of commercial interests of extending the life of satellites, because if you extend the life of satellites, you don't need to launch another satellite. So you're essentially reducing the debris in some way, because a satellite which is not dead, it's not another debris, and operators can get revenue. But on the military side of things, which I don't want to touch on this panel, I think it's very clear in the recent week, actually the activities that are happening in geostationary orbit, about how it's actually compelling commercial entities to sort of step into this domain. So I would just leave the floor open to everybody just coming in and speaking about these aspects. Thank you.
Thank you, Arun. Actually, in fact, while introducing this topic in the conference, we were thinking, because it's an extremely complex activity, doing the kind of ISAM activities, that is in-orbit servicing, assembly, manufacturing, resource utilization, and it's a pretty complex, pretty expensive, and I must applaud the industries, space machines, and what Siddharth said and all. I mean, it's extremely. I must compliment these guys who ventured into this kind of activity. So we were even thinking whether one of the recommendations of this Congress should be the national governments, like Indian government, could even think of establishing an ISAM fund, for nurturing the outer space economy kind of thing. Let's see what comes out. At this stage, I would like to request the audience, if you have any focused question, please also tell for whom you are targeting the question, because not for me, definitely. And but be focused, tell only the question, so that one more chance they will have. Yeah.
Is there anybody? Actually, question is.
Sir, why don't you come forward?
Well, the question is for Dr. Saxena. You mentioned that Mr. Musk is concerned about the livability on this planet Earth, and that's why the exploration of the other habitats. Now, you also referred to our ancient Shastras, the Puranas, and if we go by that, our planet can, as per those Puranas like Srimad Bhagavatam, it can sustain for billion years more. So how are we sure that the habitats which we are planning at present can sustain life beyond that also, that we are planning to explore those? Thank you.
Am I audible? Yes. So, well, I think the key differentiation is the so-called the fact that the Earth is fragile, okay, supposedly in a big sense, and therefore whether it's asteroids or you saw billions of years, the sun is supposed to reach its maximum in less than 1 billion years, and at that time all the oceans will evaporate. Okay, so definitely there is a simulated or predicted hard limit on the life on Earth, because there'll be no oceans, no water, So the thing is that we are limited on Earth, but in space, we do not have those constraints, and therefore we may be able to live longer, whether it's in a colony or whether it's on Mars or some other location,
Actually, to take it further, you said the sun is going to reach its peak less than 1 billion years. I mean, I'm reminded of my young days as a kid. I was told there are 2 billion stars. Later on, when my children's study time was there, it became 4, 5, 6 billion. By the time of grandchildren, it's so many. So it's all varying, because these are just speculation. So when somebody says it's just 1 billion years, I think it's speculation. That's why I referred to Srimad Bhagavatam, because you referred to the Shastras. So, and how are we sure that the other locations, we don't know about them? I mean, scientifically, we feel, yes, the earth is fragile. That is because of our activities. Rather than taking care of those activities to sort of ensure sustainability on this Mother Earth, we are trying to see where else we can create trouble. That's the point.
I'm not giving my personal opinion. I'm just giving the generally accepted opinion of the astrophysicists.
I think good. Analogy and put it practice in a finite time. I mean, from the ancient stuff. Anyway, you see, this is an absolutely, evolving area, we know. An evolving area with respect to outer space, activities in outer space, as well as the space economy, which we are trying to focus now. So as we move along, as the nations move along, as the industries move along, as the researchers move along, we are sure the standards, guidelines, collaborative models, so many things will evolve and slowly fall in place. That's what we believe. So if there is no other question, I would request once again the panelists to top up,
Sir,
their own.
If I may.
Yeah, please. Yeah.
It's not a counter-argument or a point, but I got reminded of a quote actually when you brought this up. So this was during the time of the Vietnam War, that the Apollo missions were going on. And I'm not quite sure who had actually quoted this. I think it was Carl Sagan, who mentioned that while we were, dropping 20,000, kilograms of bombs over Vietnam, we had argued that we are not going to hurt a single lifeless rock. Because the entire Apollo mission was predicated on the idea of peace. But then when you look at space, diplomacy, or when you look at space, it has always been a binding force. The famous Soyuz handshake, the Apollo-Soyuz handshake, which at the height of the Cold War actually brought, two superpowers, two warring nations together. So I think we can look at it this way, that space can actually unite. Instead of it actually creating more problems outside. I do understand that when we go there, we are sort of hurting. But that's the thing, it's a lifeless piece. But again, if we can actually get the idea that, it can bring, peace on Earth, I think that is how we should look at it.
Good. Can we have the comment from
I think,
Kannan? Yes.
to top of what Arun said, I think I'd like to quote one sort of a famous dialogue from a movie called Jurassic Park. I think there's a quote called "Life finds a way," because, as you've said, why are we focusing on space when there is a lot of things going on Earth? But essentially has the sort of the DNA that humans have. It's essentially we want to explore more. So that's in our bloodline itself. So I think that the quote sort of justifies what I'm trying to say. Life finds a way. So we will essentially go out into space, and there is going to be things that we have to resolve through through what we have done so far, for the past 10,000 years we've been here. So I just wanted to point that out, sir. And regarding coming back to your question, sir, so my perspective regarding like what sort of role outer space economy could play stands on, for an Indian perspective, what I want to put that out is it stands on 3 pillars. First one is from a policy perspective, second one is from a government perspective, third one is from an industry perspective. So what do I mean by policy perspective is the sort of discussion that is going on around the world from countries like Japan, UK, US. They have started thinking about how this outer space could look like and what sort of role could regulatory bodies should play and could play. Because it's currently a wild west out in space. There should be some structure, from not just an Indian perspective, from every country's perspective, who wants to play a role in future human presence in space. So currently there is no framework as of now, but there has been slow progress and very valuable progress. So that is one point that I want to touch upon. So if we have the sort of norms and guidelines that Sir mentioned, then the companies that sort of who wants to work in outer space will proliferate. When policy aspect comes into play, then companies will also see the sort of potential that a regulatory body is moving the direction towards. So when there is direction, then there is competition. So when there is competition, there is innovation. So when there is innovation, then there is progress. So this is how usually things work. So that is the policy aspect that I want to talk about. And the second one is the government perspective. So I think this touches upon a similar point I made earlier regarding what sort of roles governments are playing around the world. Since it's a very novel thing and unique thing, everyone is trying to winging it, try to figure out on the way how what sort of role governments could play. I think Australia is one of the country who has a keen interest in outer space, and Japan and the UK and the US. And so they have sort of thought about, this is something that we could take an active role and sort of, have a discussion with other countries in multilateral forum to sort of how we are doing this, how you could participate in this. So I think this is the right time for our government as well to think, okay, this is something other countries are doing. We should also sort of take part in this. So what sort of participation I'm looking at is similar to what Sir mentioned. Can there be an ISAM fund? Can there be a national active debris removal mission? Can there be a national life extension mission for a satellite? So those are the kind of avenues we could look at. And the final pillar that I want to touch upon is the industry partners. So when you say about how sustainability in space could work, it doesn't happen overnight. There should be a participation from the industry as well. So what do I mean by participation from industry? Currently, there is no incentive for a satellite operator, not just in India, in any country, to think about space sustainability. There are some guidelines that they have to follow, like regarding deorbiting, regarding collision avoidance maintenance. But the sort of servicing and refueling aspect is, they don't have any incentive as of now. So once the regulatory and once the government role comes into play, the industry will automatically start to think about, okay, this is also something that we should work towards, the sort of interfaces that we have to look at for servicing, for refueling, the sort of the bus design itself. How can we make it easier for another company to service their satellite? So these are the 3 pillars we should start thinking about. Once we have an active conversation, like the great discussion that we are having now, then the sort of discussion will eventually move towards an implementation position. So that is something that I really want these sort of players who are active in these 3 different pillars to take an initiative. So,
thank you for that remark, Naresh. So, sir, you have any brief point? No? Okay. Then Siddharth, please.
I
I think India has arrived at the scene. We've seen success with SpaceX. We have an Indian astronaut on the ISS learning, doing experiments in low Earth orbit. As we have, our whole Indian space community moving beyond low Earth orbit, looking at future missions. One is achieving success with robotic missions. It's going to take a lot of effort at different ends to understand our place in the global ecosystem as well. There's a lot of benefits that we have, as Indians working in India, understood. How does that correlate with or immediately contribute to, requirements? The outlook as well, like what Sir started with, it was very Earth-focused space development efforts. Now we have started looking the other way, and we're looking at managing assets in space. So we are taking those steps. We're seeing, companies like Anand come out and participate actively in the SpaceX development. We're seeing companies like OrbitAid, we're seeing Space Machines. There's so many different companies that are now coming to the front, and we're at the kind of, at the edge of understanding what are we to do. So the next, I would say, 5 to 6 years are going to be very exciting, very interesting to see how we take this. It's very unique and rare to see India be at the forefront at some of these things, which in fact, as we are moving into it, the number of other players is slowly reducing, it's diminishing. We are finding ourselves to be in this unique environment that not many people have been, and that is driving innovation. That's ISRO looking back and asking for innovation to come out of companies. That's looking at foreign companies to find talent in India and set up, offices here. It's looking at finding, locally grown companies to take up those challenges. So it's kind of all happening very fast. We're in a very dynamic environment, I should like to point out. And it's important for startups to understand what has worked and what has not worked, and then, get into it. We get into that problem of building technology and then trying to figure out, and that's always, a big challenge for many companies. Every company goes through its evolution of understanding of what works and not. But I think in this particular area, it's very important for companies in India at the right time to understand from some of those experienced players to get that expertise and insights, and then, build upon that. But I think it's a completely exciting time. It's slightly early days to understand how this will play out, but I see a lot of merit and innovation happening.
Yeah, it's indeed true, because there's so many countries are signatories to Artemis mission, and Earth station, our space station wise, of course ISS is there. There is a Soyuz model, there is a Kibo Japanese module, and India is aiming to have Bharat space station of its own. Then we have heard about the Rosetta mission, ESA payload landing on asteroid. Obviously, it is not for fun, right? Basically, to exploit the resources on asteroid. Indeed, the activities outer space are growing, and most of the signatories to Artemis, it is a testimony to the intent of spacefaring nations, space agencies to get into outer space and see what best they can do. It's evolving. Hopefully, in the next year's conference or next to next, we would be in a much better position to make this session more lively and longer. Now, with these words, I would request Rajat to make his remarks, and I think time is also coming to close. Yeah, but take your time. Don't cut short.
I couldn't, to the gentleman's comment about why space or not space, I don't think I'm qualified to comment on that, but just a historical context. With expansion of any human activity in any domain, there have been 3 phases of that expansion. One's been to access it, to sustain in it, and then to leverage it to its potential. And it's been mapped to the cost of each. Cost to access the domain, cost to sustain in the domain, cost to leverage the domain. And with launch innovation in the last 10 years, you've seen this massive drop of the cost to access. And the next problem to solve is how do you sustain in domain? And sustainment requires infrastructure. whether that's security, whether that is servicing, maintenance, capability in orbit. And so before it becomes a killer app, and if you go back to the 80s and you saw internet, when companies in the US in the mid-80s were starting to connect the different sites, there was no killer app. So they were taking this big, massive risk where they didn't really had a characterized demand that they could depend on for revenue, but they also knew it was going to emerge. And so I think when I look around globally on this panel, but also globally, companies starting to look at space infrastructure as a market, it takes a lot of courage, and a lot of us will not make it. But I think what's important is that in taking this step, you're bringing the cost to sustain in space down, and hopefully when you do that, then use cases like mining and permanent habitats and everything else becomes a lot easier because then you start leveraging that domain. And so historically, whether it's land, whether it's sea, whether it's air, you've seen this same pattern, and I don't expect space to be any different. So hopefully that just gives some perspective.
Admit that it was a good learning session for me. So, I mean, with your permission, if nobody has any 1 minute or half a minute point to make, is there anybody? Yeah. Yeah, max 1 minute max. Yeah. Yeah. No. She's coming with the. Yeah.
What I'm seeing, and so happy to see, and I'm just seeing that from a real life, the Marvel movies are going to come on the real life. And these people, the Indian Elon Musk, though I should not say Elon Musk, Dr. Saxena and other guys are just making it happen. And we can work together to find out how can we make sure that we are able to realize that dream with you. That's all. It's
Thank
really
you.
Encouraging to see the different movies. Thank you.
Thank you, thank you. Sir, you wanted to make a comment.
Yeah, Naresh mentioned about refueling of satellites and other things as part of this ecosystem. Well, at present, the biggest challenge the LEO constellation is posing is the space debris. Because the lifespan of those is just about maybe 3 years, 2 to 3 years. Now, which particular fuel do you envisage to be used so that the life of these satellites can be extended? Are you talking about hydrogen fuel or what exactly?
Because this is a deep topic, I think I request that this can be discussed offline, because definitely nothing, which is prone to explosion kind of fuel only, because it was discussed in the other session about green fuel and things like that. So I think offline, is it okay, Naresh? Huh? Yeah. Is there anything else the panelist would like to add? If not, let me thank the distinguished panelists as well as the distinguished audience. And thank you so much for cooperating and honoring the words of the organizers. We are finishing the session on time.
Yes, sir. Thank you so much, sir. So as a token of gratitude and appreciation, we now present a mementos to our eminent panelists. So may I request our moderator, Dr. V.S. Hegde, sir, please present the mementos to our panelists. Dr. Siddharth Pandey first. Mr. Arun Radhakrishnan. Mr. Rajat Kulshreshtha. So that's it. To Dr. Ashok Saxena. And to Dr. Naresh Kannan. May I request D.S. Govind Rajan sir, please, board member of SIA-INDIA, please present the memento to our moderator, Dr. V.S. Hegde sir. And please put forward for our group photograph, please, to our all panelists.
We are going to start a finale of this 3-day India Space Congress.